So Shelly has all these things coming: native assets, decentralization, peer-to-peer, stake pools, the stake pool interface. It's also a new economy. And so we had to think around, how do we make this an appealing small business opportunity for people?
Hey guys, welcome back to Altcoin Buzz Spotlight with me, Layah Heilpern, the show where we speak to entrepreneurs, innovators, and thought leaders in the cryptocurrency and blockchain space. Joining me today is Charles Hoskinson, the founder of Cardano and the CEO of iohk. Cardano launched in 2017 and is set to be the third generation of blockchain of crypto, focusing on scalability, interoperability, and sustainability. After a long-awaited release, Cardano are launching new protocols which aim to revolutionize the space. Don't forget, let us know in the comment section below who you want us to interview next, which topics you want us to cover, and if you enjoyed the show, then hit the like button. Charles, welcome to Altcoin Buzz. It's an absolute pleasure to have you on the show today. There's a lot of exciting announcements with Cardano. So how are you doing?
Well, I'm doing great. It's great to be on. It's been long weeks. We always knew that June was going to be one of the busiest months I think we've ever had as a company. Everybody's working overtime. Everybody's really putting in the hours, and we're just really excited to finally get Shelly out. And also for the summit that we have coming up July 2nd to 3rd, we kind of planned that event just about a month and a half ago. We already have 4,000 people registered to go, 100 speakers. And getting all that done in a short time frame while everybody else is busy with Shelly has been definitely a balancing act, but I think we've managed to get through it.
Yeah, absolutely. Just so much compacted into June. It's a hell of a month for you guys. So we're really excited to have you on at this moment in time. It's going to be great. So before we go into Shelly, I do kind of want to talk a bit more about Cardano. I want to understand how you would describe to the layman what the differences are between Cardano compared to the likes of Bitcoin and Ethereum.
Yeah, the easiest way I think a layman can have to understand it, or frankly anybody, is to group them into generations. And each generation has some sort of first mover that was defining what was trying to what the architects were trying to accomplish. So with Bitcoin, this was the first mover. This was the first generation. Really, it was the concept of, can you have decentralized money, decentralized transfer of value, decentralized ledger, and somehow, some way, a dynamic and decentralized network will maintain that. This was not the case before Bitcoin. No one had ever pulled anything like this off. There had been attempts to create digital money, like DigiCash and so forth, but nobody was able to actually create cryptocurrency where no one owned it, no one was in control of it. Anybody could join, anybody could operate and validate the ledger, anybody could mine and so forth. And it wasn't clear if this was actually going to produce value or not, or become stable or not. These tokens were totally worthless when I signed up years ago, and then all of a sudden they became worth $10,000. So it's been an amazing roller coaster of a ride. The problem with Bitcoin is that it's very simplistic in what it can do. It's not a criticism. It was a design feature that the architects of that system were trying to push. You really can only push value around, but you can't issue assets. You can't do complex contractual relationships. You can't do dApps and DeFi and all of these things. So the point of Ethereum, which was the first second generation cryptocurrency, was to try to understand what that model looked like. So it took everything from the prior generation. So the decentralized ledger, the dynamic and decentralized control. But then it said, hey, now all of a sudden your transactions are programmable. It's almost like the web. When JavaScript came to the web browser, suddenly you went from static websites where you just, almost like a signpost or something, and they never change, to dynamic experiences like YouTube and Facebook and Amazon and so forth. And it enabled e-commerce and social media and all these other applications. So now we're entering the third generation where smart contracts are good, multi-asset ledgers are good, programmability is great. And of course, we still want to be dynamic and decentralized, but we want to do this at scale. So we want to do this with millions to billions of users. And also, we want this to work with many systems because there are over 5,000 cryptocurrencies. There's dozens of legacy financial systems. There's government settlement systems and clearing systems. There's all this stuff floating around. And it's not good enough to just say, hey, we're going to build a system that's blind and deaf and it doesn't really understand or see the world around it. We need to build a system that's aware that there are other systems and can communicate with them and move value and information. And then finally, there's this tail problem of governance, and we call it the sustainability problem, mainly who pays and who decides. So basically, every time we've been having big fights in the cryptocurrency space, they tend to lead to things like Bitcoin Cash and Ethereum Classic and these fork currencies, which are ultimately failures in governance. And it's not clear as technology gets more complicated, as the scope of these things grow, how are we going to actually make decisions without having a central entity or a governing foundation or a committee or a council? If you want to be truly decentralized, you need to have a way of making decisions. And also you need to have a way of paying for things. We had the ICO model to kind of bootstrap new cryptocurrencies, but unfortunately that money runs out. So then what happens the day after the initial wave of funding has run out? You need to have some sustainable funding source to pay for research and development and more interoperability and more scalability. So when you bundle these three things together, interoperability, scalability, and sustainability, that functionally creates what we call a third generation cryptocurrency. And Cardano is seeking to do what Ethereum did for the second generation and Bitcoin did for the first generation, basically be the philosophy on how to achieve the third generation. Now, to do this, we've had to embrace a very different way of designing things. We went back to first principles, so we assumed nothing, and we started from designing what is a secure ledger, and we wrote a paper on that. And then we got a big group of scientists together from many different universities, and we've written more than 60 papers. A lot have gone through the peer review process, very rigorous scientific papers. And we basically slowly but surely built up a corpus of capabilities, whether it be consensus capabilities or ledger capabilities or programmability or voting systems and governance capabilities. And when you string them all together, that's basically what Cardano is. It's a system that will hopefully over time get faster as we get more users. It's a system that can talk to other systems, and it's a system that has a built-in governance layer that allows it to actually allow people to vote and make decisions about what direction they want to go, and also has a built-in treasury system. So some of that inflation, instead of paying it all to the stakers and the miners of the system, you actually set some aside into like a decentralized account that the system itself can use to finance its own development. So it was a very ambitious project. We've been working on it for over 5 years. My company has about 240 people in 40 countries. About half or more are allocated to Cardano. We've written probably a million lines of code at this point, and we have quite a large community. And we've learned a lot along the way, and we're finally getting to a point where we're turning on some of the major features of the system. We're going from a static and federated system to a true decentralized, dynamic and decentralized system. And then we'll turn on smart contracts and turn on governance and all these other things. So this is a really big year for us, and it's a year, 5 years in the making. It's been probably the most work I've ever done in my life.
Yeah, and I think, I'm in crypto, and I think for me, it's just incredible just to see how far and how fast things are actually developing. First generation Bitcoin, second Ethereum, moving to Cardano, and just to see how this space is evolving. DeFi is huge right now. So seeing, what the potential is, what is coming is also so exciting for everyone. And you mentioned the summit coming up, and that's on the 2nd and 3rd of July. So what can we expect ahead of the summit?
We have to actually get a lot of the Shelly infrastructure out of the door. So right now, this week, we're doing a critical test with something called a hard fork combinator, and it's just something that allows us to go from a static and federated system to a dynamic and decentralized system. Pending these test results, we're going to release the mainnet candidate for Shelly either on the 30th or next week on July 7th. So it's one of those, if the weather is good, we get to launch the rocket. Otherwise, we have to delay a week like SpaceX does. And that's okay. That's how this works. And then we also have the new website for Cardano coming out, cardano.org, tentatively scheduled for June 30th, including all the new documentation. And we spent months and months and months and months writing documentation and, detailing the architecture and polishing the formal specs and so forth. There's a lot of science and engineering that went into that. And then obviously we have the summit on the 2nd, the 3rd, and we're going to have a lot of great announcements there. And we have a lot of great guests there. For example, Vint Cerf is coming. He's one of those guys where everybody's used his work, but nobody knows who he is. He's the father of the internet. He created TCP/IP. So we're having him on a panel where he gets to discuss what he would have done differently had he got a chance to build the internet again
Oh,
with everything
wow.
that he knows now. So that's going to be a lot of fun. And we
Yeah.
have the original Haskell committee coming back for the first time in 30 years to discuss what they would have done differently with Haskell. We have governance people coming. We have some heads of state that are coming. The Prime Minister of Georgia, for example, and perhaps a few others. And so it's a pretty diverse crowd, both politically, regulatory, legal, academic, engineering, use and utility, and commercial. So it's coordinating all that on such short notice has been a heck of a lot of work. But it's fun because it's a virtual summit, so it's free to attend. And it's the first time we've ever done it. I think we're using MeetU as the platform, and basically we just flip a switch and anybody anywhere in the world can attend. And it's
Incredible.
a great place to make announcements. It's a great place to kind of demo and showcase some cool things. Like, for example, we're going to be showcasing our identity management system we built for Cardano called Prism, where we're integrating the DID standard. Something comes from the W3C and the DIF. Those are the same guys that standardize HTML and CSS and so forth. And Diff is been led by Microsoft and other companies. And we kind of get to talk about how we're going to bring identity into the future and enable self-sovereign identity and allow you to own your own identity as opposed to it being
Wow.
issued to you. So that's really important because you see topics like security tokens and DeFi and so forth. Those regulated products almost always have an identity and a compliance component to them. And it's not clear how are we going to decentralize that? How are we going to pull that into the blockchain space? Because you're only as good as your most centralized component that you have in your stack. So even if your currency is decentralized, if somebody controls your access to that, then you're not really decentralized. So you need to have every component be that way. So Prism's an example of where we're kind of liberating identity and pulling it out of the traditional way of doing things and allowing people to do things in a more blockchain-oriented way. So we'll have a presentation on that, a lot of discussion about governance and voting. We kind of have to be armchair politicians and imagine what an ideal system would look like. And then, of course, a lot of discussions about what does it mean to issue an asset on Cardano. We have a very different way of doing that than Ethereum does with the ERC20, which we argue is much better. So we're going to be talking about what that looks like for both the fungible and non-fungible side and the permissioned and the non-permissioned ownership side. So utility versus securities. And then a lot of discussion about what it's like to write smart contracts in our system, because what we feel is a much more natural model for smart contract development and dApp development, but it's quite different from the way that Ethereum's done things because we spent 5 years building it from first principles with formal methods and peer review. So lots to discuss and lots to kind of build our way up to. But it's just a nice event. And moving forward, what's cool is we're on such a great release cadence now. We were kind of in development hell for a long time as a project. And now we've got to a point where every 2 weeks we have releases in our software. So, literally twice a month or faster, you get new features and new functionality. And we're speeding up and accelerating. And we're doing so with some of the highest quality code that's ever been written in the history of our space because we're using a really scientific language, Haskell. And we're using formal methods with that, which is the same engineering standards that NASA uses and SpaceX uses for their rockets and for their life support systems and so forth, where if the system fails, you lose billions of dollars and people die. So it's best that it never fails. But unfortunately, writing code that way is really, really hard. I think
Yeah.
that's why we have more PhDs and mathematicians and computer scientists than any other cryptocurrency project. There's probably 3 or 4 dozen of them from schools like Cambridge and Oxford. But to get that to work in an agile way and with reliable deadlines has been a big challenge. But we finally found a way to do that. So moving beyond July, it's we just get to enjoy the acceleration of progress and the fact that people are going to be able to use Cardano to do a lot of really useful things and build a lot of great utilities.
Yeah, and you mentioned you've got to get it right because if it fails, then there's people are going to lose billions of dollars, as you said. And I know there's been some criticisms over how long it's taken, but absolutely right. You've got to get that right. And I think with the summit coming up, it's going to be so fascinating just to have that juxtaposition between the people that were behind the internet and what we're seeing now, the future, essentially what's coming from you guys from 2020 onwards. So I think that is going to be fascinating. But I want to talk about Shelly for a second. So the incentivized Shelly testnet phase has been a success. So how do you actually measure that success? And could you share the numbers with us?
Yeah, that's a great question. So we launched the incentivized testnet. Like all experiments, you don't know how it's going to pan out. And basically, the idea was that we wanted to build up we wanted to do two things. We wanted to build up a large group of operators that would be capable of running Cardano. And so it's one of those field of dream things. If you build it, they will come. Well, we hoped that they came, and they did. Over 1,200 stake pools showed up, and they registered and they started operating the network, and they turned the ITN into basically a full cryptocurrency. It's a fully decentralized system that at the moment is 100 times more decentralized than Bitcoin. So it's pretty amazing what they've achieved in short order. The second thing is that Ouroboros is a totally new protocol. And what people don't understand is that it's a protocol born of rigorous academic theory. So there are mathematical proofs behind it. This is not the case for the vast majority of protocols that are developed in our space. There are a few exceptions like Algorand, for example. But for the most part, it's unique in that respect. However, being born of theory, there's a gap between theory and application. And what we needed is to have a sandbox with real money at stake that would allow us to verify that the assumptions and ideal functionalities and other things that we'd kind of hand waved on the academic side weren't going to come and bite us somewhere. So we needed to basically verify that Ouroboros works in practice. And we now have 6 months of examples of data that we've been able to collect with real rewards being paid to people. So they behave just like they would behave under the normal network. And a lot of people tried to crush the network and break the network and do all kinds of shenanigans. And yet it survived for 6 months. And that's a great victory for us. So I think it's the first incentivized testnet that's ever been done in the cryptocurrency space. But it's a mission accomplished. It inadvertently created a cryptocurrency along the way. And now the community kind of has to decide what they want to do with it. But it created a great class of operators, and already a few hundred of them have ported over to the Haskell side and are now running the Pioneer testnet to verify that everything's working properly. And we'll even create a course probably on Udemy to explain how to run a stake pool, and it's based heavily on the lessons that we've learned from the Pioneer testnets and the ITN. So that's basically what it is. It's a like a real life testing sandbox. It's like a little world in a box. And we get to use it to verify that all the things we thought were true were actually true before we play around with the $2 billion actual Cardano network.
Yeah, and we've been speaking a lot about Shelly, so I kind of want to go into it now, understand what it is, because it's the biggest launch in Cardano's history. So explain to me, how is this going to evolve Cardano and essentially evolve the space, really?
Yeah, it's actually one of the hardest launches, I think, in the history of cryptocurrency. It would be like Ripple waking up one day and saying, hey, we don't want to run our own network anymore. We want to go switch over to proof of stake or something. When you get a big network effect, tens of thousands of nodes, dozens of exchanges listing you, people kind of get used to a baseline level of operation and logic behind that system. And you're unable to really make dramatic changes without a lot of effort. So, for example, Ethereum's going through this with ETH and ETH2, where they're right now in a proof of work system. They have about $26 billion worth of mining capacity there. They have kind of a way of how Ethereum runs. And now they're trying to throw all that into the trash can and say, okay, let's go to ETH2, and it's a completely different way of running. And, it's a Herculean effort to upgrade. Well, similarly, it's the same for us. Cardano's been out as a cryptocurrency in a mainnet, running in a mode quite similar to how Ripple runs their network since 2017. And now we're saying, hey, guys, on July 29th, we're going to flip the switch. And instead of having a federated set of nodes running this, now you are running this. So we had to come up with all kinds of mechanisms to make that as graceful as possible. So basically all a user has to do is just download an update for their wallet, and then it kind of works. But then the people responsible for running it are also well trained to come in and do it correctly from day one. So we had to invent things like a hard fork combinator that allows us to gracefully go from the Byron era consensus rules to the Shelly rules. That took months of research and a lot of very sophisticated code, so that it's just like flipping a switch and doesn't really disrupt anything and no bad user experience. We had to train up all these pioneers to teach them how to run it. We had to come up with a decentralization metric where over time more and more blocks are made by the stake pools as opposed to the federated actors. So instead of just going from federated to decentralized, you go gradually over time. And we also have to turn out all the peer-to-peer components inside the system, and that'll be done over the next few months as well. So it's a huge upgrade, and mostly because we prioritize user experience and prioritize no disruption of service. We also have to get all the exchanges to upgrade as well. And we've been working directly with Binance and other partners, and we completed a completely new way of listing ADA. We have something called Adrestia, and it has all these beautiful libraries, and it uses GraphQL. And we try to make it so that it's super easy to list ADA and for an exchange operator. And it's very secure, and it's built with the formal methods and everything. So it's probably one of the most reliable wallet backends and nodes that they've ever worked with. But getting all the APIs right and getting it to a point where exchanges are comfortable with it has been quite a challenge. And we've worked with a lot of major exchanges to try to polish that and also future-proof it, because Cardano is going to be a multi-asset system. We wanted to make it easy if you issued an asset on Cardano for an exchange to list that asset if they've already listed ADA. So they don't have to do anything special. They just, kind of flip a flag, and then suddenly you have liquidity with that. So there's been a lot of foresight that we've had to put into the architecture as well. And that team has been working for over a year and a half with partners to try to get to a point where all those things kind of come together. And so Shelly has all these things coming: native assets, decentralization, peer-to-peer, stake pools, the stake pool interface. It's also a new economy. If you're a stake pool operator, you're a business, just like a mining pool is a business. And so we had to think around, how do we make this an appealing small business opportunity for people? And how do we make sure that they have the tools and the support that they need to succeed as a small business operator? So we have a great dialogue with these stake pool operators, and we have several Telegram channels with thousands of people in it. And we regularly communicate with them and survey them and focus group them, and are actually even building special tools just for them, from data visualization tools to tools to help them advertise and so forth, so they can be competitive. And Daedalus itself, our canonical wallet, even has a stake pool center. So when you click on it, you actually display all the different stake pools, and it's like a marketplace, and you get to decide who you want to delegate to as well. There's a lot of other ecosystem things that we've had to work on, like trusted hardware. We're working with Ledger and Vacuum Labs, as well as Trezor, and we're updating them so that they support Shelly, and it's easy to use them with Daedalus and Yoroi. But then also it's easy to use them to stake. So you can do cold staking, where you can leave your private keys on the Ledger device, but then you can also use that device to delegate to stake pools right from the Daedalus interface. So you have the security of a hardware wallet, but then you also have this beautiful, easy-to-use interface to delegate, and you don't have to really worry about the security side. So this is an example of just all the stuff that's happening with Shelly, and there's just so many teams and so much code. I think there's like 7 teams working full-time, and they're all polyolithic, so they're building individual components, and then they have to wire all those components together, and that's what we've been doing over the month of June. It's been a hell of a lot of work.
Yeah, it sounds it. And, talk about user experience and, that being a priority. And I think that is so important, particularly when we look at mass adoption and how we're going to sort of make this thing bigger. And I think, that's one of the biggest problems. But very interesting with regards to Ledger and cold staking and all that stuff. So really excited to see what comes out of Shelly. We spoke about proof of stake. So let's go into that a little bit more, because Cardano is pioneering proof of stake. So talk to me about the history of it, and how does it actually help with decentralization?
That's a good question. So the problem with proof of work is that you get a lot, but you give up a lot. So we weren't actually sure all the things that proof of work gave us until we actually started writing formal papers. So the first part of the research agenda in 2015, when we got started with Cardano, was to do a really deep and rigorous scientific analysis of what is a blockchain, what is proof of stake, what security properties are nice to have, which ones are essential for decentralization. And we modeled all of that in the GKL paper, which has over 800 citations now, and we've updated it probably 3-4 times since it was originally published. And basically that gave us a security baseline to have a conversation about, if you were going to build a competitive protocol, something to compete with this, to get rid of some of the trade-offs, what properties must that protocol satisfy? So we started the Ouroboros agenda in 2016, and we've written 6 papers now, and each and every one of them have been gradually building up the security properties of proof of work. So basically an equivalent protocol in terms of capabilities. But you have much better trade-offs. So when you think about these protocols in general, they generally have 3 steps. You have to decide somebody has the right to update the system. So there's like the first step of picking somebody who gets to go from block 1 to block 2, block 3 to 4, 4 to 5, etc. Okay, then second, that person has to make that block in a proper way. And then third, he has to propagate it through the network, and the network has to accept it as legitimate, real. So proof of work, 99.9999% of all the energy and difficulty goes in step one, that selection part. So that's what mining is all about. People are looking for a magic set of numbers that if they get it, it gives them like a golden ticket to advance that network. Okay. So what proof of stake does is it says we're going to do all three of those things just like proof of work does. However, for that first step, we're going to create a synthetic lottery instead of a mining meritocratic lottery. And we're going to use an internal resource instead of an external resource. That internal resource is the token. Now, this is a really interesting idea because what you're doing is you're directly aligning the success of the network with the resource. This is not the case with mining. In mining, if you have miners, if there are many chains that follow the same consensus algorithm, you can choose to mine, Zcash over Ethereum or, another proof of work system over Ethereum or whatever. Mm-hmm. You can just repurpose your GPU or your CPU. Whereas proof of stake, you can only perform actions within that system. So you're endogenous, you're within the system. So it's a different model, but the benefit is that you don't have any energy consumption for that lottery to select a winner. So instead of consuming more energy than the entire country of Switzerland, you can build a system at the same scale and use 10 kilowatts of power, which is about how much power my farm here uses. So it's pretty extraordinary, the energy savings that you get. And also you have an incentive to reduce energy consumption and reduce operating costs, whereas proof of work has the opposite incentive. The more valuable the token becomes, the more energy gets expended. And there's nothing you can do to kind of make that a better scenario because any power efficiency gains that you have means that people just build more miners. They don't actually run it at that lower power rate. So it was very difficult over the last 5 years to figure out if we could theoretically match all the security properties of proof of work, because there are a lot of great ones. It bootstraps from Genesis. The synchrony model is really desirable. It has adaptive security because you don't know the miners ahead of time who are going to win, so you don't know which one to DDoS. There's a lot of magic there with proof of work, and we had to work really hard and put a lot of very sophisticated cryptography and invent a lot of new concepts and new theory to get to a point where we felt very comfortable with our proof of stake model. And it wasn't just us. We set a very high bar. So when we wrote a paper, we submitted that paper to an academic conference. This is another thing that we've done that other projects have not done. So if you become a computer scientist, a professional cryptographer, generally the metric of success is, can you publish your work? And in the computer science world, publications are generally done through conferences, not journals. So the most prestigious conferences in the cryptography world are Crypto and Eurocrypt and CCS and so forth. And generally speaking, for every 10 papers submitted, 1 to 2 are accepted. So it's very hard to get your papers in. And we've consistently done that. Ouroboros has been accepted at Crypto, Eurocrypt, CCS, and other major venues year after year. And some of the world's top cryptographers have not only read the papers and critiqued them and improved them, but they're starting to do derivative work as well. So that means other scientists unrelated to Cardano, unrelated to IO Global, unrelated to us, are actually taking our work and using it as a basis for future research. Like recently, there was a paper out of UIUC and Stanford that was written called Nakamoto Proof of Stake, which is a derivative of a research line that we started. So that's very encouraging because it means that they've accepted the ideas to a point where they're willing to improve them and bring new ideas to the table, which is exactly what you want to look for. So there are trade-offs. You have to accept endogenous security versus exogenous. There's different incentive models and so forth. But overall, the benefits of proof of stake are enormous. You get significantly better performance. You get flat energy consumption, so it's much more ecologically stable. The fact that you can build things like stake pools mean that you have dedicated actors that are on 24/7 your space to enhance your network protocol or build interoperability layers for Lightning and Hydra or for side chains and things like that. So cross-chain communication. So there's just a lot more that you get with this model, but it's a very expensive model from a research perspective. It takes years and years and years to get it exactly right. It's the same for Ethereum. They've been working on Casper stuff for as long as we have with Ouroboros. And Algorand actually, I think the first publication there was in 2016. And this was out of MIT with one of the world's greatest living computer scientists. And they're just now starting to commercialize and roll out that technology. So it's not for the light of heart. It's definitely a lot of work whenever you want to improve things and move the trade-off profile. And then obviously the market has to decide. Right now we're still a majority proof of work market, but over the next 24 to 36 months, we'll see if that paradigm shifts and proof of stake becomes the majority. Who knows?
Yeah, well, I mean, I didn't use the word pioneering lightly when I said that, because that's clearly, what you guys are doing. But with all of that in mind, then, do you think that Cardano could become more decentralized than Bitcoin? I think I know the answer to this, but go on. Great to hear your thoughts.
Well, yeah, and that depends on your perspective. So there's decentralization in terms of development. There's decentralization in terms of the quantity of full nodes. There's decentralization in terms of the operators of the consensus algorithm. And in that last category, that's a very low bar. Bitcoin is among one of the most centralized of all cryptocurrencies because the economics of mining tend towards vertical integration, subsidized power, and private mining pools with ASICs. And so basically what that means is that if you want to be a miner in Bitcoin of any prominence now, you have to invest hundreds of millions of dollars into building a private pool. And in many cases, they actually create their own hardware, which is not publicly accessible. So the everyday mom and pop, that resource that you buy to participate, in some cases, you can't even buy it. And if you can buy it, it's meaningless because your contribution is very small. Now, compare that to, a proof of stake style system. Tokens are always available on exchanges. There's always liquidity. There's always a person willing to sell. So it's much more egalitarian, and it's easier to get access into that system than mining provides. So decentralization of consensus is a low bar on the proof of work versus proof of stake side. On the other hand, Bitcoin is a very decentralized ecosystem in terms of the amount of available full nodes, and a very decentralized ecosystem in terms of development. There's a lot of Bitcoin developers floating around doing things. So that's a lot harder. And there you have to have a good governance system to compete fairly. So you need to have an improvement proposal process. You need to have a good voting system. You need to have dedicated funding for independent developers. You need to have alternative clients. You need to have reference specs. There's a lot of dimensions that you have to work really hard at to try to achieve that scale. Ethereum has definitely achieved it, as have certain other projects. Ironically, some very centralized projects like Hyperledger Fabric, for example, there's a lot of adherence and decentralization of development there through the Hyperledger group. And we have a pretty good strategy for how to achieve that too. So I believe over time, because we have better economics and we have a better strategy and we have the benefit of hindsight, we can achieve a lot more there than Bitcoin has, because Bitcoin's kind of stalled out. There's no more diversity that's being added, and I don't foresee them growing beyond where they're at in terms of decentralization of development, decision making. They're pretty comfortable at this stage, but I think we can leapfrog them there. And we have already, with the ITN, demonstrated 100 times more decentralized than Bitcoin's core nodes. Their mining nodes. So we're going to beat them easily there as well. But there's a corollary to decentralization that's really important, and it's not mentioned often in the space, which is inclusive accountability. So what that basically means is you check each other's homework. So one of the core tenets, philosophies of Bitcoin is that anybody can run a full node and anybody can validate history and verify history is correct. So when I send your business a Bitcoin transaction, your business is able to verify that those coins exist and that they have not been double spent. Now, the problem is that this only works until it doesn't. And what I mean by that is Bitcoin is currently a replicated system, like most cryptocurrencies. And as a consequence, once you get too big, it's going to be the case that very few people are actually going to have the resources necessary to verify truth. Okay, so let's say your blockchain gets to many petabytes or exabytes in size. Okay, well, that means that only Google or the NSA or some big agency would actually have a full copy of the history. And so if somebody sends you a transaction, you'd lose the property of inclusive accountability. You'd no longer be able to verify if the coins exist or if they haven't been double spent without trusting a central actor. And this is actually one of the reasons why the block size debate was so pernicious. What the core developers realized that if they let the block size grow without bounds, and within 10 or 15 years, the Bitcoin blockchain would just simply be too large for any normal computer to host it. So only a small group of actors would actually run full nodes. So the system would become less decentralized over time. It'd be like a bacteria colony poisoning itself after it's grown too large. So that's a big challenge, and it's a problem that has yet to be fully resolved in our space. But it's a barrier for large-scale decentralization. When we get to millions to billions of users, there's going to be millions to billions of transactions and millions to billions of utilities and things going on, and so the system will be just simply too large for any one actor to possess the whole thing or run a full node.
I want to move on just to focus on use cases now, Cardano's use cases. So can you talk to me about your plan to actually onboard more use cases, DeFi, enterprise, and of course, stablecoins? I'm quite a fan of stablecoins, actually, so this will be interesting.
Yeah, we have a whole working group on stablecoins in particular. It's led by Bruno Paleo. He's got 2 doses of brains. The guy's a brilliant man. And he's actually a logician. There's not many proper computational logicians floating around. So he studies logic and computer science. He has a PhD in the topic. So he gives these beautiful presentations that are incredibly rigorous, and you can never argue with the guy because he's like so damn logical in everything he does. You're like, okay. So we have a whole group that does nothing but that, and we are actively looking at all the basic DeFi utilities like DEXs and oracles and these other things. And Emergo, one of our sister companies, they decided to partner with a blockchain called Ergo, specifically for rapid DeFi prototyping that's easily portable to Cardano, because Ergo is a derivative project from a project that we had in our company called Scorex. So the next 6 months, as we turn on Goguen capabilities, so that's native assets and smart contracts, we're going to basically get some funding behind a lot of pioneers and build up a beautiful DeFi portfolio. And the advantage that we have is that the first generation of DeFi that we saw out of Ethereum, it has the dual problem of a lot of design flaws as well as operating costs that are simply just too high for them to be viable. So we have an advantage to kind of redo and learn from all of their mistakes and basically build our own DeFi portfolio that operates at a much lower cost. It's much more interoperable with the regular everyday world, and we feel that it'll probably be much easier to use. So the key is to get the right partners and the right funding before the partners. And we'll have a lot of announcements about funding and partners at the Virtual Summit in July. And throughout the year and next year, we'll be aggressively building that up. And it doesn't take a lot of time to deploy these types of things. People have this belief that, it's years and years. Well, it's years and years for the first example. Mm-hmm. Like Bitcoin took years to build, and it took 5 years of Bitcoin floating around before people even thought to build something like Ethereum. But then after Ethereum came out, the smart contract model became very well propagated. Now everybody's got a smart contract model. Yeah. So similarly, it takes years to build the first set of DeFi. But then once that idea is out, we can rapidly learn from each other and evolve from each other and get a completely new set of DeFi. And the unique advantage that we have at IO Global is that we're heavily invested in the developing world, like Ethiopia and Georgia and all throughout Africa, all throughout Southeast Asia. So we have the ability to deploy these solutions and applications at a scale of millions of users. We do one deal, we get 6 million farmers, or we do one government deal and they'll give us a monopoly to work with their entire country. And these are examples of where DeFi is most useful. You need decentralized lending there. You need better ways of deploying stablecoins because the local currencies aren't so good. You need better marketplaces to trade securities on because in some cases they don't even have a stock market in that country. So it's not good enough just to build the capabilities or have a great platform to host those capabilities. You have to have a customer base that actually is useful for those capabilities and wants those capabilities. And this is not the case where Ethereum is principally at. It's mostly in the Western world. And people are like, well, why do I need a peer-to-peer lending thing if my bank is willing to give me a loan? Why do I need a stable coin when the US dollar or the pound is relatively stable? Why do I need these? But when you're in Ethiopia, there's capital control. The currency is not very stable. It's impossible to get a loan if you're in the rural areas. It's impossible to get insurance policy. So it's no longer a question of replacing an incumbent. It's becoming the incumbent. And what we have is unique market access there to bring these services to millions of people. And actually, ironically and paradoxically, it actually allows us to compete better in the Western world, principally because we can create new financial products from the fact that these people are in the system that are very appealing to the Western world. And I'll give you one quick example. So right now in Ethiopia, they have a fertilizer voucher program where basically farmers get vouchers to buy fertilizer and they have to repay them at some point. Well, these vouchers get repaid with interest and they have an incredibly high repayment rate, like well over 90%, which is unheard of in microfinance. And so you can imagine creating financial products, debt instruments like fixed income securities that basically have a 15-20% interest rate with a 90+% repayment rate. So they're actually high quality credit with a sovereign guarantee behind them. And then you could securitize those and sell those through Goldman Sachs and other things in the Western market. And all those securities live on a blockchain, on the Cardano blockchain and so forth. And the advantage here is it creates liquidity. So it can bring billions of dollars of capital to the poorest people in the world and allow them to be able to build infrastructure for their farms and plant crops and build wealth. But basically also in the process provide a very attractive financial instrument that can be traded in the Western world. So these are examples of that marriage of the developing and the developed world, if it's done correctly, where you can get great customers and their existence brings new products to the Western world for us to mutually benefit in. And the Western world brings capital into the developing world, which allows them to accelerate their growth.
And it's, for me, it's, that putting people on that financial map and accelerating that growth, as you say. And for me, that's one of the most exciting use cases of all of this. So really exciting stuff there. But just finally, you mentioned Ethereum, and I have to ask you, of course, about Ethereum because, we've got Ethereum 2.0 coming out soon. So there must be something interesting about the update that excites you.
Well, I don't actually know when Ethereum 2.0 is going to hit. I don't think they've been fully honest about that rollout. And also, I don't think they fully thought through the consequences of the upgrade that they're doing. We did. It took us years to figure that out. And it's not going to be the case that when we go from Byron to Shelly, that there's going to be Cardano Classic running on Byron and Shelly running at the same time as its own chain. I think there's a very high probability because there's $26 billion worth of mining capacity running on Ethereum that there's going to be an Ethereum Classic. So the original ETH is going to run in tandem with the new Ethereum. So they're still trying to work their mind around all that. And we wish them well. And we hope that it's a successful upgrade. But let's be clear, they're firing their miners. The people spent years building up all these dedicated operations and are mining Ethereum. And then suddenly when F2 comes out, all of them go out of business. And, people like Vlad Zamfir and others have been incredibly dismissive, called the miners mercenaries and useless, and we want to put them out of business. So out of spite, maybe those miners will keep the original Ethereum rolling, and that will actually become its own chain. So there's always the risk of that. The other thing is if they honestly believed that F2 is out tomorrow, why are they even talking about ProgPow? That's what I've never understood. So why would you switch your proof of work mining protocol to a different protocol when you're planning on already throwing away all of your proof of work protocol? It just seems like a pointless debate to have. That said, F2 is converging to a design that probably works. However, it's mired in complexity, and I think it's unnecessary for what they want to accomplish. I mean, sharding the ledger is probably the most dramatic and difficult thing you can do as a project. It's very expensive. It's very time consuming. It reduces your security from half Byzantine resistance to a quarter to a third, depending on how you do it. And at the end of the day, there's just so much more complexity that you now have to think about with the sharded ledger. And then, availability is always an issue, and you have to think about that. What we chose to do is use a single shard environment and embrace an L2 solution, Hydra, that will allow us to grow to millions of transactions per second without having to shard the base ledger. So we can use much more classical distributed systems theory and just optimize that. And it should work for 4 or 5 years worth of growth in our system, if not more. In fact, at the moment, what's coming with Shelly would be able to run pretty much all the transactions that you would normally encounter with Ethereum and Ripple and Bitcoin combined, and still be able to operate on a single shard environment. So I just don't see the necessity to embrace something this dramatic. It's the classic case of chasing sexy technology for the sake of sexy technology, not realizing that you're getting yourself a really difficult tail that's going to be hard to work through. And, big companies make these mistakes. Intel chased Rambus, and they threw in the towel eventually and went to DDR RAM. Then, Nissan went with the CVT transmission, and that was an elegant, beautiful piece of technology, but it took generations and generations to get to a point where it was reliable. So I think they're going to have much more problems with this transition than they're letting on. And it's not clear if the benefits are going to be significant. On the other hand, it's going to be the first example of a purely sharded thing that we all get to learn from and see. So there's a lot of great academic knowledge that will be gained from this movement of this model. Their accounting model is also going to work against them, by the way. The whole global state thing that the EVM has is not amenable to sharding, whereas extended UTXO, the accounting model that we use for Cardano that we spent years designing, is. It's much easier to shard that. So, these are examples of where sometimes your design hinders your ability to innovate, and you have to go back to the drawing board. And that's why we chose to use first principles, because we kind of knew where we were going from the very beginning. But, all cases, EOS, Tezos, Ethereum, all these things, their upgrades are as beneficial to us as they are to them. And we have the privilege of being able to learn from it, not have to pay for it. So we're actually pretty excited that they're choosing a different model than we're choosing, and it'll kind of be the market's decision whether they want to embrace something built on granite with peer review and safety and stability, or kind of an experiment that has a poor track record of having things explode in the user's face, like the DAO hack or the parity hack or other things, and the core entities never pay for that. It's the users who end up paying for that. They're the ones who lose hundreds of millions of dollars every time these things occur.
Well, Charles, with all of that in mind, then, I want to thank you so much. It's been such a pleasure having you on the line with us today, because like we discussed, you're doing such pioneering work. So for me personally, it's just such a pleasure to hear it from you directly. And I want to wish you the best of luck with the upcoming launches in the next few weeks.
Absolutely. And we'd love to have you at the summit if you have some time. It's free to register if you just go to cardanosummit.iohk.io. And I hope there's a link in the show notes. We'd love to have you there. There's going to be a lot of great newsworthy events. Hopefully you can score some cool interviews with some old legends. Stephen Wolfram's going to be there. I think he just figured out how the whole universe works. And we said, Steve, would you like to present on that? He said, sure. So that's going to be fun.
Absolutely. I want to thank you so much, and I'm looking forward to the summit.
Cheers. Thank you so much for your time.